Shed keeps falling down? Fear no more, because WeBeam Structures is on the case. As assigned by the CIVL201 staff team, the DCCZ design team has constructed a design model for a portal frame shed, implementing all the design parameters described by the client. In order to create an effective and reliable design, the team used Revit modeling software, coupled with the structural analysis program called SpaceGas to ensure all the components of the structure met the design criteria and withstood the design loadings. Here is the basic layout of the portal frame warehouse design. Some of the key features include the portal frames making up the main structure, the purlins and girts running along the frame providing lateral support for the portal frames, and also a fixing point for the wall cladding, the roof at the desired pitch, and lastly the interior mezzanine.
In the initial phase of our design process, we created a model of the portal frame using an advanced design software called Revit. We meticulously tailored our design to meet specific parameters, drawing inspiration from the renowned Lysat steel catalogue. Our structure's foundation is a robust 18 by 21.4 metre concrete slab with a depth of 400mm. This ensures a stable structure. There are 7 interior unrestrained columns which work in harmony with 12 restrained columns on the exterior, forming the core support system of our portal frame. The rafters grace our design with a subtle 6-degree incline, purpose-built to withstand the critical load of 12 kilonewtons in live conditions. Along these rafters, 6 evenly spaced Z purlins feature prominently. The framework is meticulously completed with 5 C-section girts on each side, thoughtfully placed to avoid interfering with the placement of windows. For the roof and walls, Cliplock Classic 700 and spandex sheets were used respectively, ensuring both durability and longevity for the exterior of the structure. Within the structure, there is a mezzanine level situated 4 metres above the concrete, with a total surface area of 104 square metres.
Using SpaceGas, the portal frame structure was analysed with the different load cases as per Australian Standards 1170 Revision 2 of 2021. This included the live load and dead load, as well as wind loads experienced on the structure both internally and externally. As per client requirements, appropriate joints and connections were designed into the frame to ensure adequate support was achieved when during worst case load scenarios in Wollongong region which can sustain winds of up to 162 km per hour. The joints chosen for the structure are fixed connections, and the design team designed the bolted apex and corner joint connections as well as the bottom concrete plinth support as a base for each column, further supporting the structure. The structure withstood the live load of 12 kilonewtons per metre, which was a criteria for our team to design around, and the dead load of 0.1 kilopascals, with points of maximum stress shown in the current slide.
As demonstrated by the SpaceGas model, the design put together by our team satisfies the requirements outlined. However, SpaceGas can analyze a more efficient design for the structure. The closest specs for the rafters and columns were selected from the SpaceGas library, resulting in 410 UB 49.7 rafters and 460 UB 74.6 being chosen. The design tool then reduced the rafters to 180 UB 16.1 and the columns changed to 250 UB 31.4s for the internal frames. As for the external frames, columns were reduced to 180 18.1s and rafters reduced to 310 UB 31.4s. These reduced in size, maintaining the factors of safety and thus reducing the total cost. Overall, the portal frame structure design is a simple, structurally sound system that will resist all the design loads. Detailed analysis from the bending moments, shear force, and deflections are shown here.